Kuznets environment curve after some kind of magical inflection point. In fact, we could have had clean development all along. It isn't as if we had to go through a couple of hundred years of filth and pollution to reach the level of civilization we had today. And almost none of the renewable energy sources we are turning toward today, albeit at a snail's pace, are really novel. The 19th century saw an explosion of commercial applications for renewable energy, and almost 100 years after the birth of the steam engine that ran on the pressures created by hot water, in 1816, Robert Stirling invented the first practical example of a closed-cycle air engine that ran on the pressures created by hot air. So politicians could be used to power, heated air. The now famous Stirling engine made plumbing for energy production a whole lot safer and easier, and the Stirling engine was so efficient and so silent that it was used much later by the Nazis for some of their U-boats. Once the Brits, Michael Faraday and Joseph Henry, completed their analysis of electromagnetic induction in the 1820s, and the Frenchman Hippolyte Pixii built the first dynamo or electric generator in 1832, the path was paved for a completely clean, healthy future. Electric cars were developed and sold in the 1830s that used electricity from batteries to drive the dynamo to spin the wheels, and generators were built that used the spinning of the dynamo by mechanical means to create electricity. Electricity could power a tremendous range of things, and all that had to be figured out on a case-by-case basis was how to provide the best motive power for turning the dynamo. Hand cranks and bicycles and water wheels and windmills were immediately applied to the task, as were the new heat engines. Battles ensued over the cleanest and most effective ways to make things spin, whether wheels or turbines or pistons, and alcohol fuels, particularly ethanol, became hugely popular. So popular that Henry Ford's first Model T cars, actually Model A cars, ran on it, alcohol, A for alcohol, in 1908, long after other people were driving battery-powered electric vehicles. 1860 had witnessed the first solar power system developed in France to produce steam to drive machinery, and by the end of the century, solar-powered Stirling engines were shown off in Egypt by the French. At the same time, in the late 1800s, the German-American engineer Schumann built a massive concentrating parabolic solar thermal field to provide the energy to pump Nile water and run generators and machinery in Ma'adi in Cairo, Egypt, which became famous in 1911. They built this because politics created a coal supply crisis in England where the dirty fuel came from, and the Egyptians and their international partners wanted to have a competitive textile industry and realized clean, abundant solar power gave them a competitive advantage. The system was dismantled at the beginning of World War I when oil was discovered in the Middle East. Meanwhile, commercial hydroelectric power plants were being built in Wisconsin by 1882, using water to turn these dynamos, and commercial windmills in Cleveland in 1888, with geothermal power plants using the Earth's free steam in 1892 in Idaho. There were so many ways to spin a dynamo. Dynamos weren't the only methods people were exploiting and exploring to create electricity. Sir William Grove invented the hydrogen fuel cell, which we now associate with spaceships and futuristic cars, in 1839, and it started finding immediate applications. Battery technology also started improving rapidly and dramatically, so that by the early 1900s, Edison and Ford joined forces to create the Ford-Edison Electric Car Company, using Edison's marvelous and inexpensive and long-lasting, over 20 years, nickel-iron rechargeable batteries. Hybrid vehicles, particularly the diesel-electric train that used the constant RPM of a generator running on diesel fuel to create electricity to power electric motors running the wheels, were explored in 1903 and put into regular service by 1925. And everybody knew that a diesel engine could be run on straight or used vegetable oil with no processing. Solar cells were discovered by 1876, which witnessed the first demonstration of generating electricity directly from sunlight in a selenium solar cell. And by 1905, Albert Einstein published his theoretical paper explaining and describing the photoelectric effect, a paper that earned him his Nobel Prize. Funny how what he's remembered for is his theoretical work on splitting the atom, which was put to immediate use, while the solar electricity work that he did languished until Bell Labs commercialized solar cells in 1953. Einstein also invented the Einstein refrigerator, not theoretical. Like solar cells, it was a practical invention that used ammonia, or nowadays lithium bromide, and a heat source, biogas, for example, to create cold. The timelines show us that scientific papers were being published proving the greater efficiency and economic promise of alcohol fuels and electric vehicles, and federal laws were being passed in 1924 to try and stop the oil industry from polluting. In fact, a paper in 1896 by Nobel Prize-winning chemist Svante Arrhenius established the science behind climate change and warned humanity of the dire effects of fossil fuels. We've known these problems all along and known their solutions. In fact, the real battle was between those like Thomas Edison and Henry Ford, who had a Jeffersonian vision of a decentralized, agrarian-based society where every farm produced not only food, but fuel to power the country, and a centralized, urbanite-controlled industrial society where robber barons manipulating fossil fuels whose supply they can control call the shots. Think Rockefellers. It may be as simple as that. In an alternative universe that had no fossil fuels, it's likely the steampunk era that we read about and read about in science fiction would have begun in earnest. We may well have seen the future Jules Verne described in his lost novel, Paris in the 20th Century, written in 1863, which the famed author of 20,000 Leagues Under the Sea and Around the World in 80 Days couldn't get published because his literary agent deemed it too far-fetched. It predicted that by the early 1900s, people would be whisked around a super clean, efficient city in cars that burned nothing at all, and instead used compressed air to move through tubes crisscrossing the city. Only today are these compressed air cars jumping back off the drawing board, but of course, it has always been possible. Expansion of fluids or gases, whether due to heating them slowly, as in a Stirling engine or steam engine, or exploding them suddenly, as in a combustion engine, or through the release of compressed air, moves pistons or turbines. What's the problem? Far-fetched? Today, Luxembourg is launching the AirPod 2 compressed air car, which was featured on Shark Tank, a real blast of air from the past. Others of Jules Verne's far-fetched ideas were put into practice quite soon after he wrote them into his novels. Submarines, airships, balloons that could go around the world in 80 days. Of course, they all had military uses. But some of his best ideas were put on the back burner or buried, particularly those that don't have military uses. Consider how, for example, he wanted to power his submarines and his utopian civilization. In his sequel to 20,000 Leagues Under the Sea, The Mysterious Island from 1874, Captain Nemo explains his vision for a fuel cell-powered future. Water will one day be employed as fuel, that hydrogen and oxygen of which it is constituted will be used. That's me trying to do James Mason, who played Captain Nemo in 20,000 Leagues Under the Sea, the Disney movie. Watch it. And then go to Disneyland Paris, where they have a recreation of the steampunk Nautilus. But it wasn't just fictional scientists who saw a clean and materially and energetically abundant future. As John D. Rockefeller and Standard Oil began to manipulate the market and drive a monopoly into place around the world ruled by oil, ushered in through the conspiracy of prohibition and the destruction of the electric trolley system of mass transit that dominated America, the great inventor Thomas Edison was quoted saying to Harvey Firestone of Firestone Tires, "We are like tenant farmers chopping down the fence around our house for fuel when we should be using nature's inexhaustible sources of energy, sun, wind, and tide. I'd put my money on the sun and solar energy. What a source of power. I hope we don't have to wait until oil and coal run out before we tackle that." Thomas Edison is also famous for having said, "If we all did the things we're really capable of doing, we would literally astound ourselves." And that leads me to the conclusion of my ruminations. As we whiz around the global timeline, our time-space continuum line, exploring when and where different inventions and ideas first appeared and how they were received and thought about and implemented and made manifest, or squashed and made invisible. We see that there really is nothing new under the sun, and no real reason, from a scientific or technical point of view, we couldn't already have achieved a sustainable society. When we, if we, at last get there, we will be kicking ourselves, realizing that, as we learn at the end of The Wizard of Oz, we've always had within us all the brains, all the courage, and the heart, to say nothing of the technology, the so-called magic slippers, to get to that home away from home on the distant horizon. The laws of physics and chemistry and biology haven't changed, and most of the things that can save us from disaster were not only known long ago, but are actually very simple. Whether it's solar energy or biogas or wind power or fuel cells or electric cars or heat pumps or even cars that run on garbage, like in Back to the Future, we have to go back to the future and realize that all that is really holding us back in the present is our lack of political courage. As the Pulitzer Prize-winning scientist René Dubos said, "Creating a desirable future requires more than foresight. It demands vision." The time-space continuum timeline of renewable energy helps us use that vision. For as Abraham Lincoln said, "If we could at first know where we've been and whither we are tending, we could better know what to do and how to go about it." Now it's time for you to use this knowledge and make that better world here and now, today. Get to it.